So we are starting our fourth session on regulatory challenges in smart distribution networks. And may I request Sri A.K. Saxena ji to please uh, share the session. How do we put it?
So a very good morning to all of you. I think as it happens in every conference, the attendance starts to be good in the first session, and then maybe it peaks in the second session and it tapers down on day 2 and towards the end of the conference. So we find very few participants or attendees to be here, but thanks a lot to all of you for coming here. I think there are some people who have joined online. So very warm welcome to all those who have joined online. So thank you so much. So I think when this topic of, when we decided on this topic, regulatory challenges in a smart distribution system with DER and storages, I did not know how challenging it would be even to outline this topic. So I really, Professor Abhijit, and we discussed about it, all of us, but I thought today I found it very challenging to put the regulatory challenges. I thought the regulatory issues are all the more, we could perhaps flag, that will be good enough. But the regulatory challenges, maybe Mr. Pandey is there from the GERC, and he will be able to tell more on the regulatory challenges. That's number one. Number two, I think electricity is a commodity where we try, I think there is something peculiar about it. And what I find about whenever the demand of any commodity increases, everybody is very happy across the value chain. Starting from the manufacturer, the transporter, the supplier, the retailer, everybody is very happy. And they gear up for the high demand season and the Diwali or the Shera or whatever we call about, or a New Year or Christmas. But electricity is a commodity. When demand increases, I think we start feeling uncomfortable, because how are we going to meet the demand? That is what is the most important challenge. And we have to be preparing for that. That is what is the biggest challenge for the electricity utility, and also for the system operator, all the more important. And the primary responsibility of a distribution utility or a distribution system operator or whatever operator we call about is to maintain the continuity, reliability, and quality of the supply. And that challenge becomes all the more important with the increasing penetration of DERs. The active distribution network management becomes all the more difficult and important. That is what is there. Now, I would like to only say that when I try to look at that, the what could be the issues and challenges. So I think I tried to identify 6, 7 challenges which are there. So first and foremost, I would say is the understanding the consumer expectation and behavior, particularly in the behind the meter activity will become all the more sort of a voluminous or aggressive, and that will give lot many challenges to the operators, to the planners, to the regulators. Then situational awareness, I think I have already touched about it. I think we want to understand their behavior, and how do we try to gauge that what is going to be their behavior in the sort of times to come. Then there will be operational challenges, because there'll be reverse power flow, there'll be harmonics, there'll be other attributes which are there. So there'll be operational challenges, technical challenges in terms of the protection system or any other issue which we talk about, whether the network needs augmentation, strengthening, any other aspect we can talk about. Fifth, I would thought about the organizational and human resources challenges. The organizational re-engineering would be required. I think we have talked about in our report that there will be some model of the DSO which will be there, which model they adopt about. They carve out an entity from this, and ultimately they have to move on to the independent system operator at the distribution level. That is the organizational challenge will be there. And the human resource challenge, the capacity, the capability, what is required to be meeting the emerging requirement, that becomes extremely important. Transactional challenges. Professor Avyangso talked about the market, and I think there will be multitude of sort of a DRs, not only acting as a consumer, but as a prosumer. I think the transactions are bound to be there at that local level, and I think those challenges will become very, very significant in the times to come. And I think blockchain and all those technologies will become important, and the settlement can be there at the local level. And last but not the least, the commercial challenges, the accounting, settlement, all those challenges which are there. So I think this is what I tried to sort of think through about these challenges, which these are the main sort of areas one can think about with the emerging smart distribution systems. So with this, I would now request Mr. S.R. Pandey. A very warm welcome to Mr. Pandey. Mr. Pandey is the member in Gujarat Electricity Regulatory Commission. It's so nice of him to have spared time from his busy schedule and come to attend the seminar and deliver his impressions about it. So Mr. Pandey has a slide presentation, and I would request Mr. Pandey to first come and please. Somebody has to help him to project his slides.
Thank you, Saxena. Good morning to everybody. The topic is regulatory challenge in smart distribution network. So it is a new topics. It is not a conventional topics where you can workers discuss about what are the reform sectors, reform is required from power sector, what are the challenges in system operations and other things. These are new topics where the regulators has to come in role, and he has to protect the interest of the three important pillars of the electricity sectors. One is consumers, second is licensee, and third is generators. So the electricity nowadays a commodity which is required for life protection of the peoples also, because without electricity, if 5 minutes light is gone, people are disturbed immediately. Psychological, they feel that the light is not available, these things. Similarly, now EV is also penetrated more and more. So in case of the non-availability of electricity, charging is not possible. And if charging is not possible, vehicle is not charged. In that situation, the person who has to drive for the electric vehicle, he also disturbs. In these situations, the regulators, what is the reason behind the creation of the regulator? Intent of that things, Parliament has enacted the law with intent that it is an expert body, consists of different people from legal, technical, commercial, finance sides experts, economic side experts. So 3-person body who are expert in different subjects. They can understand the subject, they can frame the regulations, and they can regulate this business. So important of the role of the regulator is quite different than the either on legal side, on particularly who are educating, just like a high courts and other things. Major role is to regulate the tariff supply, as well as to provide the foundation for utilization of distribution network, transmission network, as well as the generating assets. So optimum utilization of all assets of the either generating station, transmission systems, or distribution system is one of the important factors which require to be verified by the regulator. Similarly, the viability of the any sectors, either distribution, generation, or transmission, is depend on what is the cost incurred by them. And real time, in time, they receive the revenue. So whatever the cost they incurred is timely available to them, so that the licensee will not suffer or generator will not suffer by way of the pending dues, and they require working capitals and other financial measures to run their business. So regulator role is important specifically with regard to tariff fixations, timely pass the orders, and made the mechanism that whatever the incremental cost, if any, happen, that will be passed on time to time to the licensee, so that they are not burdened with the revenue gap and other things. Similarly, tariff structure is also very important, because different type of consumers, we are having agriculture, BPL, industries, low tension industry, high tension industry, railway, all these different type of utilities are working and consumers of the licensing. So the tariff structure, as far as simple, is possible to came out by the regulator, so that it will reflect true cost of the energy supply by the licensee to the consumers. That is a very important role. So in that background, the Gujarat Electricity Regulatory Commission, also constituted by the government of Gujarat, where the commission is carry out the various activities, and role of the regulator is very important. Here, this side we have shown that Gujarat distribution companies are A plus graded in the country. They are given loan at very cheaper rate of 8%, 7.5%, or 8.5%, which is not able to achieve by the private companies also. The reason is that the commission is passing the order, tariff order, in time before 31st March of the financial year. So the 1 year is available to the licensee to recover the cost which is expended by them as a part of revenue. Similarly, applicable PF formula, fuel cost adjustment charges formula is derived by the commission, where on quarterly basis, whatever the incremental cost of the fuel or power procurement, we pass on to the licensee. So the incremental cost is not accumulated on annual basis. Just like an example, after COVID, non-availability of coal, where is different part of the countries, demand is increased, but fuel price is quite increased. Imported coal price is also increased. So pass-through mechanism which provided by the commission as a formula, it helpful to the licensee to meet out their incremental cost by way of FPPA. An annual gap will be reduced. And at the end of year, when true up carry out by the commission, the true up, the gap of the licensee will be as far as possible low. And generating company also able to get their dues in times. So no regulatory assets has been created in that aspects. Particularly, the commission is also verifying the capex, because the licensee generating company come for the capex carry out for their business to maintain the business in proper forms. So the commission is approving the capex, but with consideration of the cost benefit analysis, uh, providing loss trajectory or implementing technical parameters like SHR, auxiliary consumptions, and other things. So the benefit is available to the generator licenses, and same may be passed on to the consumer cost as a part of efficiency gain. So as the Act has provided 4 objectives to be achieved by the Act. First, to bring competition, to bring efficiency, to bring transparency, protect consumer interest, and also environmental benign policy, because the India is one of the member of treaty and protocol where the environmental norms which is fixed at international level, it also required to be followed by the coming government, and it will become as a part of different agency in different act, so that the renewable promotion of renewable energy cogeneration are one of the part of that, for to meet out the obligation emphasized by the government of India in that aspect. So the commission has played major role by protecting the interests of consumer, licensing, and generator. And due to that, the discoms of the Gujarat having A grades, and they are also benefited in different way also. As an example, recently or in past also, various competitive bidding carried out by the distribution licensee, juvenile, as well as Torrent and MPSEZs of Gujarat. And they received the tariff is quite lower than the competitive bidding carried out in different states. Just like recently solar tariff, solar bid invited by juvenile, where the tariff discovery is 2 rupees, 2 rupees 42 paisa, where in other states at the same times, the tariff discovery is 2 rupees 89 paisa. The reason is that the licensee having good balance sheets, and generators are having confidence that their money will not be restricted, but the licensee is paying the amount of their dues in time, and also they are getting 2% or 1% rebates. So they actually try to operate in commercial way where the interest of the consumer, licensee, and all people should be protected. So regulator role is very important in such a way. Similarly, while framing the regulations, it is very important to see that what the regulation we are going to frame, and what are the challenges, how to be framed out, and what are the important factors required to be considered. Just like a example, in country, various states have framed out the forecasting and scheduling of renewable energy regulations, where the limit for deviation permitted is 15%, penalty 50 paisa per unit, and also the change in the forecasting schedules is given for wind and solar 16 times at any times. And also the such changes are permitted at 1.5 time hours after their things. While framing the regulations in Gujarat, we have allowed 16 deviations, 16 time revision in wind, and 9 time revision in solar, because solar is not available in night. So this is a simple issue which required to be carefully verified by the license regulators. Similarly, while linking the penalty is not, it is not a penalty. It is a, we have to see that the generator can be provided opportunity to improve their forecasting and schedule so that the grid operation become easy and as far as possible correct. So the penalty we have decided to keep 2 rupees 25 paisa with consideration of discovered tariff of 2 rupees 50 paisa. So 10% of the discovered tariff is nearby is a penalty amount. These are the various roles which require to be carried out by the regulators. Now, role of the regulators at present and in past future also very important, in which first thing is come from the state government. It has to provide autonomy, competent people to be provided there, and transparency of the regulator is required, important. Regulator has to derive the regularly tariff and see that it will be the licensee or generating company able to recover fixed cost and variable cost. Third element is subsidy, which is provided by the government. That is, as far as possible, it will be provided through direct tariff benefit transfer schemes, so that it will go to directly to the person who are benefited from it. Now, the topic is particularly so far as modernization of the distribution system by smart grid or smart network. What is the reason why it requires? First, age-old distribution network, because the distribution network which has been created having either completed their life or somewhere it is not operating proper way due to no proper O&Ms and other things. And it is very old distribution network where technical as well as other challenges are also available. Unreliability in costing consumer crores. Power supply which is received by the consumers are sometimes unreliable. In continuous process industries, if power supply is gone for 15 minutes or 20 minutes, it hamper very harshly to such industries. Their product cost will be increased, the process will be restart, and other things will be affected. So they, for reliable power, they can either keep DG sets or other things, or they can also require to keep other resource source so that continuous power supply will be available. So unreliable power supply or is very important, is also affecting particularly industries just like data centers, large industry, steel industry, copper industries, all these things where continuous power supply is required and intensive power is required. Third thing is vulnerable to attack the natural disaster. Cyclones, floods, which are comes in different part of the countries where the whole distribution network, transmission networks are affected. So restoration of that things also very time consuming. Number of days people are deprived from the lights and other things. So to avoid that part, modernization is required. An extended loss today distribution network could cacophonic to our security, economy, and quality. Loss in terms of transmission distribution losses, commercial losses, as well as earlier stated, unreliable power, non-restoration of power supply in time are cacophonic. It affects our security. It also affects our economics because the production is affected. Consumer are deprived from the supply and other things. So it having multiple impact on techno-commercial aspect, not only on the licensee, but in also state as well as central government, because government is also getting taxation from the manufacturing sector, services sector, so that will be affected to that aspect. Present distribution network does not address the 21st century power supply challenges. As stated earlier, Mr. Saxena, that now distribution generation, distribution resources are also coming in picture. So the consumers are setting up their rooftop, the licensee also providing benefit to the consumer to set up the generator at their own pumping station, railways, their agriculture pump sets also. Also, the feeder solarizations and other things take place. So the end portion, earlier conventional method is that generator is at our end, it will be transmit and power supply come at thousands of miles away from it, and from that substation it will go to the consumer end. So consumer end substation where the supply is received is always generally keep higher voltage, so the voltage available at the consumer end will be at required level. So if 11 kV supply is received at consumer level, the supply at particular substation level we will keep either 11.4, 11.5. So the voltage development drops which has happened in line will be not affect consumer to the power supply. Nowadays, the distributed generation, just like a solar, a hybrid, or battery storage, or rooftop, is provide the power supply at the consumer place. So the end of voltage, which are 11.4, it is increased, then higher than it provided voltage level is keep higher. That generation is available. The voltage supply level will be more and more. And end consumer supply, in spite of 11, it will be 11.2, 11.4, 11.5. So this is the one of the challenge which also required to verify by the regulators while framing the regulations so far as the quality is concerned. Nowadays, also rooftop is increasing. Distributed solar generation is also come nearby the substation and other things. So the rooftop solar, which is provided at the consumer place, it also create harmonics or other aspects, technical aspects. It affect because the supply system is made in such a way that it will receive the power supply. Here they work as a generator, so the transformer it work as a reverse in reverse way. So transformer will generate and supply. So LV side become HV and HV side become LV. Sometime it may be possible. So that is a challenge. The benefit of modernization distribution network are substantial. That is also it required to compare and verify that. This is the smart distribution network hard transform. As a distribution sector, just like center is provided center is a distribution sector, which is connected with smart energy control system. It is connected with inter-region transmission system, renewable energy generator, conventional power plant, storage system of pump storage or battery storage, and also having electric vehicles connected with them. So the smart or distribution network are important for by way of improving efficiency, reduce energy consumption and cost, and maximize transparency. It will provide two-way communication. Earlier method networks are having single-way communication. Here, two-way communication are possible. And it will also deal with the global warming, emergency resilience, and energy independent scenario. This is the future electric energy control center. How it can work. It is a control room which is connected with advanced distribution management system, ITO sensor which sense different types of things, GIS system which will carry out through mapping through satellites or drones, other things, advanced consumer management system, smart meters, advanced analytical tools. So advanced analytical tools like AI, machine learnings, and other things will helpful to analyze the huge data which is receivable through these distribution networks by the control rooms. It is also deal with the EV charging management system because EV charging is comes. So now at present the EV charging comes with a time link situations. But it may be possible that fast charging will comes that within a 2 minutes or 1 minute you can charge the vehicles where they draw the huge power from the systems. So in that situation, how to manage this EV charging station is one of the important factors which require to be considered by the commissions or regulators or licensing perspective when they are making the distribution network. Similarly, distribution resource management system, DR, and other things, and asset performance management. At present, the conventional methodology, there is no particularly asset performance management is verify and controls. But by adopting this smart distribution network, it is possible to verify the asset performance management from the aspect. What are the characteristics of the distribution network? Smart distribution network. First, it enables active participation by the consumers, accommodate all generation and storage options, enable new products, services, and market, provide power quality for the digital economics, optimize asset utilization or operate efficiently, anticipate response system of disturbance, so self-healing. So it is a one of type of new ring fencing system where you can restore the power supply within a 15 second, 20 second, 30 second, according to your softwares and ring fencing system, because the power supply is, in case of fault, it will be available through different source at the same time. Operate recently and against attack and natural disaster. Now, smart distribution network, how bring the gap from with consideration of today network and what is the tomorrow network comes. So far as enable of consumer participation, at present, consumer are very less aware about the price visibility. They are sometimes somewhere they are charging time of use pricings, and some choices, few choices are available. They are majorly dependent on the generator or licensee who are supplying. Now, by way of smart distribution system, where the DRD distribution generation, distribution resources are available, at that time, pool price information is available, because if carriage and container separated, pool price information is available. Different distribution licensee provide that information. Choose from many plans. Different options are provided by the licensee as a business models, prices and options buy and sell available to the consumers. Just like a rooftop, they are buying power at X time and selling power at Y times. So peak demand, they are sometimes producing, or they are generate power supply by way of rooftop net metering or gross metering. Gross metering, they supply the power at relevant times and other things. Accommodate generation storage. At present, dominated by central generation, little distribution generation, DR, and storage of renewable. Here, the many plug and play distribution energy resources complement central generation. Just like a rooftop distributed solar generation at substation level, as well as fleet based supply, storage based supply, where the fleet is having power supply, and it can be possible to charge 5, 10, 20, particularly electric vehicles, or the same fleet may be able to supply in rural area, or particularly some rural area, this separate distribution microgrid system is also possible to provide that part. Enable new market. At present, the wholesale market is not well integrated. By way of this smart grid, mature, well integrated wholesale market growth and new electricity market available, because the communication from the distribution network available with the transmission systems, market developers and other things. Meet the power quality. Focus at present on particularly power quality with respect to the outages, to minimize the outages. While in future, it will be priority with variety of quality, harmonics, fluctuations, voltage level. All these are different parameters which require license, or manufacturers are required, or service providers are required for that thing that is available, and price options also needed to them. It is optimized the utilization the asset operate efficiently. The modern distribution network will deep integrate into the intelligence and asset management software, provide asset properly, utilized properly. Similarly, self-healing system, it will prevent the disruption, minimize the impact, and restore rapidly. And in case of vulnerable terrorist or natural disaster, by way of modern systems, smart systems, we can deter, detect, mitigate the resources rapidly and efficiently. Why digitalization is prerequisite for the future? As the hybrid power is used increasing, power load are varying, and by commercial impact, the digitalization is the required to improve the performance of DISCOMs and making existing government schemes, because government is also providing various schemes and funding where they are providing for efficiency improvement. For that, it can be utilized efficiently. The digitalization will enhance cloud computing, data collection, and ability to interpret the collected data, which are in huge, by way of artificial intelligence, predictive machine learning, and blockchains. Distribution digitalization part of the smart grid is reliable, secure, economics, efficient, environmental friendly, and safe. Now, change management, because now from old regime to new regime, when you go, it is very important, because the player who are involved, they are acquainted with the change management. For that, communicate a vision. What is the vision? how it can be achievable. All people who are stakeholders are communicate that vision, strengthening the consumer education, consumer who are the end users. After all, the use of utility, they can understand then for what are the benefits of the modern organization of the distribution system, align stakeholder around the vision. So all people have been aligned with the vision, which is emphasized by the regulations or generators. Provide motivation, develop metrics, monitor, and keep in mind. And in all these things, regulation framed by the commission are very important because the regulation is a sub-legislation whereby all people are bound to implement that things. So it is a very important role of regulator in these situations. Now, regulatory aspect, when the commission framing the regulation, it will require to incentivize the investment of digitalization or smart distribution system, which consists of time-based rates, means the rates which has been provided or fixed by the commission, by that will be incentivize the consumers to become actively involved. It also more favorable depreciation rules because the old asset which is not completed their life has been required to be replaced. In that situation, unutilized life or cost is passed through depreciation. So earlier retired asset may be given accelerated depreciation. Policy change, they provide incentive and remove incentive policy. So investment distribution system should require business sense. It make business sense in that situation. Clear cost recovery policy, the cost which has been incurred by the licensee or generators, or whatever it may be, that can be recover investment. So that risk may be avoided. Societal benefit will be addressed by the in the regulation as a business case to include societal benefit by improving, providing the digitalization, what are the benefits available to the society, consumers by way of reduction in outages, quality of power supplies, and other things. Similarly, consumer market participation is very important, where the consumer can verify the different options available. He reduce the fixed requirement, grid investment and modernization, and cyber security is also one of the important factors which required to be considered. Balancing the capex and opex required for infrastructure, keeping the tariff under control. So excess capex or opex may not be provided. Demand forecast with consideration of the change in behavior of the utilization by the consumers, and as well as the demand fluctuation due to fluctuation in resources, climate change, etc. That require which verify, and it will be considered by the commission while having the regulations. Techno-economic issue due to shift of radial flow of distribution electricity, city distribution system, challenging assuring quality power supply, improved power supply, reliability, keeping energy cost in varying demand supply chains. Similarly, demand side management, shifting of consumer power consumption practice, limit the peak, investigate the potential key enabler and associate development in the planning and transformation, promoting flexibility use of electricity along with selection of resources and ensure competitive environment. These are the different technical challenges which like standard of interconnection, interoperativity, integration of different type of energy sources, distribution system behavior, well understood, decade behavior, competition, and other things. Now, other challenges are that part big question is that what do energy efficiency and environmental goals suggest? So when you go for the smart distribution systems, what are the energy efficiency, environmental goals required to be achievable? And if you go for this network changes, how determine the cost? What is the optimal cost? How it will be effective? What are the options available? That will be also one of the challenges. Second main change is that who pay the smart distribution network, which is huge cost is required for that. Who pays, whether licensee pay, government pay, consumer, or if it will pass on to the consumer in present regulatory mechanism, the tariff will be increased too high. So different distribution network company business model is required, not merely only to it will supply other services just like energy management, communication, where the profit opportunity are available by use of the asset properly, they can be regulated. And who particularly, one thing is very important, who own the information that smart distribution network collect, because the consumer data, behavior, consumption patterns, all these things are available with the use of these things. So that data is a business model for the any manufacturing service providers and other things also. So that data, how to be handled, it is one of the important factors which has been also required to be verified, and if that information is available, it any profit margin is available from that is very important to verify. Retail pricing more accurately reflecting the true and economic cost of the generation of delivery is all price structure is concerned. Now, as the government is promoting for clean energy options, it is required to see that build energy efficiency power plant into power sector structure. There's different different way planning, marketing, and market development possible. Increase investment in renewable energy by way of integration through larger regional operations, so that the surplus energy, if renewable available in one part of the country or one part of the state, that will be transferred in the same part of the other part of the state or in nearby other state also. Improved wind and solar energy generation forecasting, hybrid mode generations, strong grid code is required, state of the art turbine and inverter technology. At present, the technology are used by the turbines and inverters, because the integration of the renewable as far is increasing. The grid code provide that particularly they have having particular type of wind turbines and inverters. So in case of non-requirement of energy, that can be restrained by way of the smart grid or smart technology, that generation will be reduced or stop in case of grid, grid management point of view. Flexible resource and ancillary services, financial reward for the generator that can operate at lower level, start quickly or respond quickly to operate signals, so that in case of emergency, when integration of the renewable energy is increasing, in that situation, flexible generation will be very helpful. Demand side management is one of the important factors, and charging plug in electric vehicle is also one of the important. Thank you.
Thank you so much, Mr. Pandey. I think it was such an exhaustive presentation, and we really appreciate it, and the inputs which we got about are really valuable to the community and the project team as well. Now I request Professor Anjan Bose from Washington State University to deliver a macroscopic view, a comparative analysis of the policies and regulations which are there in US and India. Professor Bose, please.
Thank you, and good morning. First, I'm sorry I walked in late for my own session, and I was kind of at the mercy of the transport provided. And since I was traveling with two very famous American professors, I can blame it on them that we were late. So secondly, I don't know anything about, or I know very little about Indian regulations of the power industry. And so I can't say very much about that, but if you hear somebody like Mr. Pandey talking about things, you already get the idea that doesn't matter where you're in the world, the regulations of a complex technical and industrial thing like the power grid is rather detailed and rather complicated, and of course produces lots of controversy as well. But so I thought I'll touch on two things. One is somewhat the how does it work in the US as opposed to how it works in India. And then the second thing is what are regulations themselves in a big way? What counts as regulation? So one of the issues, of course, is that regulations depend on the structure of the industry itself. So it's not sort of stands by itself. And for example, in the US, we say that the whole power industry is a regulated industry. And what does that mean? And it actually means quite different from here. You see, as I said before, about 70% of the customers in the US are supplied by private power companies. Okay, and a private power company which are monopolistic because nobody else serves the area that one power company serves. So, and that's why you have to have regulations. You can't just have one power company have full monopoly on supply and then do whatever they want. So each of these power companies, the private ones, are under the regulation of the state in the US. Every state, whichever state you are operating in as a power company, that state will regulate. And one of the most fundamental things that they regulate is the price that you pay. Okay, and so there's a government body, a regulator, often called the Public Utility Commission in the state. But that's only one aspect of regulation. But the difference is this: in most other countries, the power companies are government owned. Okay, and that makes also a lot of sense because electricity is somewhat like any other essential commodity, like water, like roads, right, like railways. These are always, in most countries, are government owned. In the US, water and roads are government owned, but many of the electric companies are not. The railway system is not. The railway system is private, and so there's this organizational difference that changes the way regulations is done. So if it's government owned, then the purpose of the regulator is to have an independent body making some of the rules under which the power company works. Okay, so every country has regulators that regulate the power grid. Okay, so that's I wanted to kind of say that even though people say regulations or regulators, it means slightly different from country to country. Okay, and then I should also say that because India and the US both live under a dual legal system in the sense that there's the central government that sets a certain things, and then there's the state government that does things. And as you know, the central government, CERC, for example, sets regulations for the bulk power system, and the state government sets prices and things. This is true for both the U.S. and India. But it also produces problems. Unlike, let's say, in France, there is no difference between the central and state. That it's one regulatory agency. Whereas the U.S. and India, being large countries, we have the state versus central thing. So certain regulations are done here, and certain regulations are done at the central system, and so you quickly realize that these things have to operate together. I mean, you can't have part of the grid being told to do something and part of the grid being told to do something else. Now, I think it's worse than that because there are 29 states in India, and if these states have different regulations and they're all connected to each other, I mean, you run into problems of things. So one of the big realizations in these things that it becomes very complex, and it requires lots of negotiations, and it requires lots of thinking and having comment states. You put it out there, when you have everybody who's a stakeholder have to comment, and so it becomes a very complex, lengthy process. So unlike, say, engineering, which has got a step-by-step kind of thing that you do, regulations have a kind of a circular rationale to that. Okay, so then the other thing that I wanted to point out is that for most of us engineers, we don't differentiate very much between the words policies, regulations, standards, These are all kind of those things that non-engineers do, is our perception of this. But actually, there's a structure to all of this. And for example, I usually think of policies as being those rules that are made by the legislature or parliament, right? Those are policies. And so parliament, and I'm sort of throwing in the prime minister's office and the chief minister's office among the policymakers. And here also things get complex, right? I mean, India is represented in the Paris Accords or the COP decisions at the national level, right? So they come back and they say, well, we promised to do such and such with the cleaning up our generation by 2050 we'll get this much less emissions, and then by 2070 we'll be fully clean and all of this. And then the state has a completely different idea, right? Rajasthan says we're going to put so much solar in there. Right? Now, who's coordinating all this stuff? Right? If you add up all the cleanliness that each state has promised to do, does it add up to the whole national policy? Okay, so these are things that at least engineers get worried about. I don't think the policymakers get worried too much about this thing. They make the policy, and there's somebody else is going to take care of actually making it happen, and it usually falls on the engineer to do it. So this is sort of working backwards to saying that most of us engineers, we start out wanting to do engineering things in life, build better control centers, build better design principles for smart distribution systems, these kinds of things. And it's only much later that you realize that some of these things are being driven not by how efficient your processes are, but it's driven by some of these things that are being decided by the other side of the office buildings, and you're being buffeted by this. And so, at least for me, it took a long time before I said I better pay attention to some of these regulations. And maybe I should actually speak up about some of these regulations, because it doesn't make any engineering sense. And if the engineers don't speak up, then the assumption on the other side is that the engineers already know how to do this, so I'm okay, We're going to shut down coal plants by next year, all right? It seems like a nice thing to do for the saving the world, but the engineers will figure out how to make the electricity, right? So this is why I think we should pay attention, and why I think it's on the venue on the session today that we are talking about these things. So let me kind of point out. So there's policies that are done by the legislature, by the government. Then there's the regulations, which is set up. So we set up regulatory boards to do these things, and they have to coordinate. And finally, of course, standards, which are closer to the engineering heart. Okay, we say we need standards because, if I do it this way, then I want my neighbor state to also do it this way. So I know we understand each other. We know which software package to use. All of these things make, and these are kind of standards. And this helps the industry as well, because if transformers are made on different standards, then it's kind of hard to mix and match these things. So those are the standards are very close to our heart. We understand it very well. When it comes to regulations, I think we can understand it, but we may not always agree with it, and we can argue about it, and we can do things. And then the policies are probably the most difficult, because they're being driven by lots of other considerations from the policymakers. Your policymaker goes to whatever it was in Egypt, and then they get pushed by other people to promise certain things, and then they promise something things, and you say, well, how are you going to do that? and I think I've said this before. For one of the more prominent ones in recent years of policy making is Germany making the policy that they're going to shut down all their nuclear plants. The only thing that they hadn't planned on is what they're going to do when the nuclear plants are shut off. And so, and since I know many of the operators in Germany and in Europe, and they said, well, there's only two things you can do if you shut down all the nuclear plants. You import more Russian gas, and and guess what happened to that plan, right? And the other thing is that their backup plan was to import power from Poland, which has the worst polluting coal in the world, right? So what was the point of shutting down the nuclear plants? It's still not understood by most, but most policymakers in Germany, they really loved it. So you see so this is why I think we as engineers need to kind of understand the whole policy making, regulations making, and all of these, all of these things. They're the most boring things to read, because it takes 5 pages of legalese to explain Ohm's law. But that's what we have to do, because the person you're going to be talking to doesn't understand Ohm's law, so you have to speak their language. So I'll stop there, and I think I'll give it to more expert opinions on regulation.
No. Thank you so much, Professor Bose. So nice of you to have presented a very good sort of a macro level points which are so important for policy, regulations, and standards making. Thanks a lot, sir. May I now request Professor Anup Singh to deliver his impressions? And my request to him is to limit it to maybe 10 to 12 minutes so that we can have 15 minutes of good discussion from the audience.
Okay. Thank you very much, Mr. Saxena. And, so as we witness in the case of renewable energy, that, when you have a forecast available few hours ahead, say 6 hours, it's not that reliable. And then you get an instruction maybe hour ahead, and then possibly you can get to change something maybe even a couple of blocks ahead. And that just happened by the system operator. So I started with a number which was probably about 15 plus, then it came to 15. And the latest forecast is between 10 to 12 minutes. So I'll try and do justice. I'm not so sure how much I can do it, but I'll try to walk very quickly. I think Mr. Pandey has covered most of the things, so things are much easier for me. And at a philosophical level, I think something which has been addressed by Professor Bose also, that where the policy gets done, and if the engineers don't respond, then you have to accept the fate, what is going to come for you, right? I didn't want to really walk through the PPT as such, but since there is a PPT, and Mr. Suni knows that I'm not really a PPT person at all, frankly speaking. We had a session in NPSC, and I had a PPT. I never want to walk through PPT because I just somehow can't put my thoughts in the PPT. So I will deviate, but I'll still walk through it because Madhav has done good amount of effort on that. Very quickly about CR and EL, so please take a look at this, but I'll tell you why I'm talking about CR and EL. We know this, so that's fine. Okay, we start from here. Okay, so preamble of the Electricity Act very clearly says we need efficient and environmentally benign policies, competition, consumer interest. I just picked a few words from there. This is something, can we put it in the context of whatever we are trying to do with the distribution network? In the context of, of course, for renewable energy, we know all kinds of policies which have been put in place. But Section 16 specifically says, okay, you have the mini grids which are delicensed. If they are delicensed, then obviously they will have certain role to play. They're already playing some role, but with perhaps more smartness embedded in those, how can these be even taken to the next level? Then you have things like open access and tariff regulations. I would like to just highlight a little bit. I think Mr. Pandey also mentioned, ultimately everything comes to the cost recovery. Some investment is going to be done, somebody has to pay for it. Either it is because in whichever way you say it is either the ratepayer or the taxpayer, they have to pay for it. Only thing is, what is the more efficient way of recovering that amount of money? You pass it through the ARR right away, recognizing that investment, or make it like an OPEX and give it on a PPP kind of a mode. But in doing so, remember, one important thing is that, of course, there is a cost benefit analysis. Mr. Pandey also talked about that in approving the investment in these smart grids. Something of that sort needs to be done with something we also been highlighting. But tariff regulation 61 clearly says about competition, which perhaps more smarters in the grid would enable easily. Efficiency, incentive for performance. This part is very important, incentive for performance. And then, of course, optimum investment. So it's not just about encouraging investment, but optimum investment, which means we also must understand the investment which is being done is appropriate for the current level, for the expected objectives over the next probably 5 to 10 years, what you want to do. So over investment is not so good because it's going to add up to the consumers' tariffs. And then, of course, promotion of renewables. So as far as the price differentiation is concerned, the important aspect is that it can be differentiated based on certain things. There could have been few more things there, but essentially, yes. Now, if you have the visibility of variety of things in real time basis also, or perhaps you can embed it in the tariff design, then you can actually monetize the investments which have been done in this smart grid. So that is what aspect I wanted to. And then, of course, you have the tariff policy and the national electricity plan, which will talk about it. Let me just skip this part also because we have covered this. Here I want to come back to the CR part, and I'll tell you why I'm coming back to it. CR was set up, I think, around 2017 or so, and we have been looking at the policy and regulatory, virtually almost all major policy and regulatory developments across all the states at the central level, Ministry of Power, Ministry of Renewable Energy, Niti Aayog, sometimes Ministry of Coal. And one of the things we have witnessed through these, and I'm only listing these policies, there are probably 100 plus on which we have given our comments. One, I'm listing these because these are one of the other ways have been related to what kind of environment is emerging, both for renewable energy development as well as for the implementation of smart meters, right? Which can link to grid code. So you will notice that there is a specific one. We gave very detailed comments to Maharashtra on state grid code, and they were amending that. And then, of course, the ERC came up with the net metering kind of initiatives, and ministry came up with prepayment plan that whole supply chain will become prepaid, and how it is going to perhaps help the system in some sense in making better commercial decisions. Right? Most recent one, of course, has been the standard of performance regulation and the UP solar policy. And I'll just refer to only these two very quickly. Standard of performance is something which is regulators designed as a measure that what kind of quality you will deliver to the consumer, not just in terms of electrical output, but the services that you deliver also. So it's not just about you say, okay, the variation in voltages and availability of power, or if the fuse is conked off, that how much time will you take to mend that. It also talks about billing efficiency, for example. It will relate to something that how many errors are there and how quickly you are able to rectify that. And please try and link it to the what is going to happen to this in the future when you have smart grids. Perhaps this billing aspect is already taken care of. Right? So that's how it becomes linked to whatever developments are happening. So there is a technological developments happening at the engineer's end, as Professor Bose put it, but at the same time, something is changing in the policy and regulation. And these are supposed to perhaps gel with each other to make sure that something which is already enshrined there, is the licensee seeing a value in making this investment, because part of his SOP targets will be met through. Let's leave the solar policy as of now, that perhaps you can check it. There was something else which happened through the investments which were being pumped from the central government. And this is the dichotomy, which is very interesting. Remember, all the investments, all the activities are happening at the, if I can use the word, end of the grid. It's not philosophical end of the grid, but it's also the physical end of the grid, which means on the distribution side. But most of the decisions are being taken at the higher end, right? One of the reasons, of course, which higher end is at the central level, because the electricity is in the concurrent list. And why it is not happening at the state level? Because most of the states are not like Gujarat. We have A ratings, right? The discoms do not have that kind of rating. They are really short of money. So the money is not available. Something needs to be done. So the money is essentially being brought about through a variety of plans for supporting certain policies. Now here, there is some gap that we often witness. So a policy is being designed from here, which happens perhaps for most of the programs, and we have witnessed it very often. In fact, I recall long back we visited some of these mini-grid projects. In fact, I ended up visiting 4 of them who had some operational challenge or the other, which Mr. Saxena mentioned about. We witnessed the operational changes, the institutional challenges, and technological challenges, whether it was biomass gasification project, solar project, and this was almost like 10, 12 years ago. We have a very highly cited paper related to that also. The idea was that, look, these projects were designed somewhere else here in Delhi. The policies were designed here. What's there in the ground, we thought it was available, right? So like Professor Bose said, the engineers will know. If you have not responded, they will assume that you can do it. And that's precisely what it is. So you have a policy which is coming up from somewhere, and it is assumed that you have done it. So if you have not responded back, and that's why I was saying that these comments are very useful, which every DISCOM should be giving, every system operator should be giving back to the respective regulators or the governments. Because if you have not said no, or if, or maybe, then it is assumed that it is done. And that leads to the failure of the project. And if we can avoid that, perhaps most of our challenges can be sorted out. Okay, just quickly telling you about what kind of cost recovery mechanism is there. Virtually speaking, you can make out it's been by the same consultant. All the documents look alike, except the only change is how much amount of investment can be approved. So for a smart grid, if you say up to 10 crore of worth of investment, go ahead and make an investment, and nobody will ask you any question. Beyond that, you please come to me for approval. Now, here comes the point which Mr. Pandey was also raising, that if you have an investment approval to be done, somebody has to justify it on the basis of the techno-economic evaluation of that. Do the distribution companies have the capabilities to check that they can monetize those benefits from these investments, and hence push for the recovery of these investments? And a lot of money is being, by the way, pushed through. So let me just go through that part. I'll just skip this. So as of now, the recent, the program which is being implemented is the RDSC, Revamped Distribution Sector Scheme, about 3 lakh crore rupees, and out of that 97 lakh crore rupees, as 97,000 rupees is going to come for government's budget support, right? Good sums of money, huge amount of money. And the objectives of the schemes are very pointed: AT&C reduction in the gap of ACS and ARR, of course, the institutional capability of modern DISCOMs, and improvement in quality reliability. Now, some of these are related to the SOPs also, this we mentioned. And now the second last slide, I think. I will probably I will avoid the deviation penalty from Mr. Saxena. But this is the number of smart meters which have been put through, right? So this data is available very easily. So Madhav just culled it out from this website. Something very interesting which is emerging, if you notice here. These are the total approved number of meters, if you see. So UP has 40 lakh meters which will be coming, and about 10-12 lakhs have already been put in place. Bihar, on the other side, if you see, is prepaid meters, right? So there's a big difference between them. Virtually same number of meters, same numbers of meters which are on the ground. But UP is all about smart meters, but Bihar is all about prepaid smart meters. Two different things which are happening in the two neighboring states, right? It's very interesting here. Now, as of now, if I want to know, or anybody would like to know really, suppose another state which would like to evaluate that what has happened. In fact, we are talking about visibility of the grid, visibility of behind the grid. We don't have right now the visibility of the benefits which are accruing from the investment. That is a very important point that we need to understand. If this much investment is happening, we should immediately work on monetizing this and ensuring that these benefits are actually somehow being recorded, so that all future investments, people see their own value. Remember, I told all the money is coming from the center. Why it is coming from the center? Why is it that the distribution utilities themselves are not finding any self-driven policy for this? To talk to a private DISCOM on its own, and I had talked to them, they are still okay without any smart meter. They would like to do it, no doubt about it, right? Because they will get an approval from the regulator, they will do it. But they are still able to manage it. One of the most important things is the visibility of behind the meter, consumer choice that can come, and of course the reduction in losses which the RDSS policy itself wants to bring. These are the just enablers which are there for that. So let me just last quickly run to the. So this morning when I got up, so I got a little bit. I said, "Oh, Mr. Saxena has already sent something." So I told him I have put it on the slide. So first 3 points I had, which were there from the title, I had just copied, and the bottom ones I made little bit of change here, and I put those points. So remember the three operative words: smart distribution system, DERs, and storage. Three kinds of things broadly mentioned. We haven't talked much about storage. So many of the challenges are there. Remember, there are two parts to it. There are some challenges which could be addressed by the smart distribution network. So that is one aspect to it. There are some challenges which will emerge when you want to implement this. So there are two different types of challenges. One you want to address and another one will appear, right? This is very important part. So definitely if you want to balance the ones in some sense, we should be able to achieve and redress those challenges which are existing. For example, poor distribution network performance or poor maintenance, SOP, which is not proper, the quality of service is not proper, and challenges that emerge is probably how do you implement it. So I'll start from in the order, like investment decision. How do you make is the first challenge? In fact, that's something which I would like to add here, because when you make an investment decision, you have to really work out what's finally going to be delivered to the consumer. Then comes the technical challenge, which is essentially what kind of standards used to be used, which Ankush and all will tell you with all kind of those numbers, and they will. Because they are the expert, or Abhijit will say about some of those technical things. So once you have sorted out the investment, knowing that there will be some technical things which you are going to order, and then there are operational challenges. Now, operational challenges, remember, one of the operational challenges is you are sorting it out from the existing framework, and the other one is which might emerge later. And what is this operational challenge? This is very important. This is something we have highlighted time and again whenever we have responded to any state regulation or the central government policy saying, look, simply smart meter there is not going to serve the purpose. It's the ecosystem, right? So you can't say smart meter. What is going to happen to that data? Are we going to use that data somewhere? It's going to be archived somewhere. Somebody will use it. How is it? The security will be taken care of. Perhaps Ame and all who they work on. And then who has the ownership of the data, and how really we monetize that data for the benefit of the discount and for the benefit of the goods for higher integration of DRs. This part is still missing. So perhaps the first implementation of smart meters has probably been about 5-6 years, maybe more than that, isn't it? But right now, what is happening is it's like saying, you have 40 lakhs, suppose, which are going to come in UP. They will be distributed probably at different places. So is the local guy knows that I'm supposed to download this data from here, and then the next guy knows this is the matrix in which form I'll get the data, and the billing guy knows if I can pick it up. But then nobody knows that what will I do with the rest of the data, right? And this is where the value was supposed to be derived. So that ecosystem is missing. So the IT systems are still not in place. They will say, no, we'll have to buy a new one, which means the decision has to start from the system design rather than individual technology being said. And of course, transactional aspect is something which is Kamini has been working on that with the P2P market and all. Commercial challenges would be less, which are related to the investment part. I have already mentioned some related on paper. I think Keval's paper has also come. There are two casings there, Kamini Singh and Keval Singh. Thank you very much. Thanks a lot.
Thank you. Thank you so much, Professor Anup Singh. Anup Singh is asking whether was it in time or not. I would say his penalty is 100%. Instead of 10 minutes, he took 20 minutes. So it's okay. It doesn't matter. Yeah, you look at the watch is there. So, literally, thank you so much. So I think Professor Ramurthy, please.
Having a good regulatory system in the state and the center. What is missing is a very strong legal system. There are cases where the governments intentionally or otherwise, they flout the rules. For example, there are many cases where the meter itself is bypassed. And I know when I was in Gujarat state, just I would like to inform Pandey, we took a survey of how sincere the consumer is in paying for the electricity charges. In many houses, particularly in Rajkot area, we found out that many meters are bypassed. What is the role of the regulator to ensure that such type of consumers are punished? They don't have any legal rights, so there should be a legal system by which I think the people have to observe some of the regulations which already are in force. And in other cases here, at least from the as a consumer, I could find out. People are not paying the charges. Meters are not bypassed here, but whatever is asked to pay, they won't pay. And the culprits are both the government as well as the private and consumers. What type of legal action can be taken against them? Unless we have got a proper legal system. I don't know, in the United States, if somebody is not paying the charges, etc., power will be cut off. But here you cannot do it. I want to just illustrate a thing which has happened here some years ago in Madhya Pradesh, Maharashtra. They found out that some minister's house, they are not paying for years together. So one foolish superintending engineer of that place went and cut off the supply. The effect of that one was that fellow was transferred. No, if we do not have a proper legal system, all these more innovative techniques and effective regulator, they cannot function properly. How do we do that one?
So far as Mr. Pandey is the best. So far as the bypass of the meters or by way of any illegal method, any person is stolen the energy or not paying the energy, there are two important sections are provided in the Act 126, which says about the unauthorized use of energy by any persons. So the purpose is he is having consumer of the residential, he utilized for the industrial purpose or commercial purpose, such type of things which is recorded in the meter, but it is qualified as unauthorized use because the purpose he has asked for that things. So in such situations, the licensee whenever come to knowledge, because the meter reading is taken place, all things is taken place. So whenever it will come to the knowledge of the consumer licensee, they can take action under 126. Similarly, in case of the bypass of the meter, the consumer just like a particularly area, one area or two area, one residential house or one industries where the consumption taken by bypassing the meters. In that case, 135 under 135 the case as you book the stolen of energy where 2 years penalty is imposed on the consumers with 2 times rates also, as well as criminal penalty also happen. So that will be go to the civil courts. So mechanism is provided. That is also recorded by the commissions in our supply code because the role of the identification of the theft or bypass of the meter or unauthorized use is identified by the licensee. And whenever it is identified, the mechanism is provided by the licensee in case of 126, or it will go to the electrical inspector because the meter tastings and other things will come picture. In case of theft, bypassing the meter, it will go to the special courts. So the mechanism, penalty, all mechanism are provided by the commission. Second thing, the commission is also monitoring interim systems as well as the data is taken by the commission because 1 crore consumers are there. So if 1% or 2%, it is very difficult to identify particular person are stolen the energy or bypassing the energy. But wherever it is found that particular feeders or area, the losses is higher, the commission is emphasized that this losses will become to reduce. Similarly, faulty meters and different data are received by the commission and called by the from the licensees, and that can be analyzed on quarterly basis, and on that comments are invited from the consumers. As an example, in one of the area, Ahmedabad, the stolen energy is quite high level. So the licensee has taken drastic route. They have disconnected with government support, police support, and reduced too much theft cases. Due to that, reason the losses in the Gujarat private distribution licensee are 4-5%, Ahmedabad or Surat 5%, 6%. Similarly, in distribution licensee where the agriculture are dominant in Madhya Gujarat or Uttar Gujarat, their losses are also 11-12%, and it having huge license area, geographical area, high level of distribution license line of the 11 kV, 12 kV, where the technical losses are high. So that is also mechanism is provided, provision regulation is provided. So that is also monitored by the commissions. But role of the commission to penalize it, all these things are not possible because the act statute is not provided, it is not fall in there. But licensees are enforcing that they can monitor that things, and they are on regular basis they are carry out the study also. They are also from the data which is received from billing cycle, they, if any variance is found, they immediately take theft drives and other things also in particular area also.
But implementation is becoming difficult.
No, because
Depends upon the position of the consumer. If consumer is very powerful fellow, nothing can happen.
no, but I give you one example. In European countries also happen. In one of the Bombay licensee, there is one street where theft is taken place. They disconnect the power supply and says that who are paying regularly, they can be supplied only by way of this smart grid system only. Those supply will be continued. Immediately, public hesitation has been started. So all different aspects will become on that picture. Regulator role is to provide the mechanism as per the statute. And second thing is licensee also required to verify that part, and commission is monitoring on that part.
Thank you, Mr. Pandey. I think it's a socio-political issue which we have, and I think we will have to see how, with the increased automation and the prepaid metering, the other forms of metering, I think there is a way to check to an extent. But yes, laws are there, but the compliance needs to be there. Thank you so much. Any other question, please?
Sir, I would like to ask question for Pandey sir. Will sir making regulation will be suffice? Why not we convert at the interface point of transmission and discom? Sinusoidal wave should be converted into non-sinusoidal wave, and it will when coming to the discom side to the consumer end, the smart meter with MAC address binding, so that you can replace the smart meter. It will not convert the non-sinusoidal wave to sinusoidal wave. So that will reduce the meter bypassing and theft.
At present, because the smart meters are not installed, once the smart meter will comes, different techniques and different technology will available by which the licensee by way from their control room, it can identify whether this what is the energy is going, what is the consumption taken place. If any bypass is there, they can switch off their supply from the control room only.
Yes.
Yeah, Professor Abhijit, please.
I hope I'm audible. Yeah. So, is there any better, effective way to bridge the gap between the engineers and the policy and regulators? I mean, Professor Anup Singh, CR and Yale, he gives his feedback monthly. My question to all: how often those feedbacks work, or what is the timeline by which it gets accepted or gets debated upon?
I would like to say that there is a mechanism. As far as the policy is concerned, nowadays even the policy making is consultative. The draft national extreme policy which was being made about, they made a committee under Mr. Girish Pradhan, and the committee invited all the stakeholders, key organizations, etc. That's number one. Similarly, if you go to the regulation making, there is a process. The commissions come up with the draft regulation, there is a regulatory memorandum, they ask for the comments, give at least 21 days, general practice. And generally what happens is the people are not responding, and even the utilities are not responding. At the state level, I cannot give the statistic, but at the CRC level, what I've seen about, many of the discoms or the state utilities don't respond to those regulations. That's number two. Number three, what is required to be done is that there is a public hearing. after all the comments come in the public hearing, and thereafter only the commission gives a reasoned order. And invariably, there is a statement of reasons given with each of the regulation wherein they are addressing almost all the comments generically, not one by one, but they will say A, B, C said this, and this is what is our view. So I think there is a process and we need to be engaging more and more. Somehow I still find after about 40 years of service that the disconnect between the research, industry and the sector professionals still remains as it used to be in our student days. Though it has improved, but still a lot requires to be done. And I think we had an NPSC session in which I was, Dr. Ramurthy chaired it, was taking the research from lab to industry and all that. So I think that's more and more participation is required. There's no other way to do. And maybe you create platforms. I feel the platforms have a great value. You create platforms, get together, meet for a day or two, and then I think try to go in that environment and try to sort of just come up with. If I pass on a paper and give it to everybody, I think we are not able to give it because we had a questionnaire which is tailored to the discoms, not to this wide-ranging audience. Just get the feedback that what do you feel is the most important, three most important regulatory issues or challenges today? Number one, column number A, and column number B, what do you suggest as a remedial measure for that? And that makes it sort of a thing. Just to give you an example, we have given a sort of asked for the feedback and we have given that questionnaire to Forum of Load Dispatchers to be circulated to all the load dispatch centers. Not even a single feedback has come. So where do you land? So ultimately the regulators take their decision and they give a reasoned order based on whatever is there. So there is a process. Thank you.
Can I just add to that, since Abhijit asked for this. See, what is happening is this question I have faced multiple times when I have talked to many people that why you work in this area. This is, I'm not an electrical engineer also, as you know, right? But how do I end up being here and then I work in an interface point in some sense. This is very important for all the engineers also to understand. You may design the best possible way to measure current, suppose, with the highest accuracy. But is there somebody there who is willing to pay for it? Is there somebody who knows how to read that meter? So that is important part. So now the objective should be, engineers should be taught two important concepts. One of them is related to economics, which is very important. Second is they should start getting a flavor of how a policy and regulatory document looks like. Because without this, I think these things will keep on coming and then we'll have an amendment, then an amendment. This is what it happens. People don't have time. First of all, the capability is also limited because capacity is limited and capability, both are limited. Number of people who are in the so-called regulatory cell, they are very, very limited. So they are not able to respond. Like Mr. Saxena said, when the CRC also has, this is worth hundreds and thousands of crore worth of impact, hundreds of crore per discom. Still, there are hardly any comments to those documents. And we try to give those comments probably on behalf of society in some sense. So I think now engineers at the master's level onwards should be taught about, please start understanding this side of the world as well.
On what Professor Anup Singh said, that regulation, policymakers, we had a subject in our engineering also where the act was taught to us. So it needs more of those doses, that's fine. But let me gather courage and say, unless you undergo test, you are never sure about your health. And everybody must go under test, including the regulators. The minimum understanding of economics, minimum understanding of power system, minimum understanding of policy making. It's not a general knowledge anymore. General knowledge is very important, I understand. But anybody coming and sitting and overnight start making regulation, it won't work. So say for example, for load dispatchers, we introduced a certification, regulatory certification, reliability certification. And I appeared in the regulatory certification. It was tough. Unless you have read those 10,000 pages of regulation, you won't be able to answer those. So my humble submission is that in the curriculum, we must introduce it. And introduce it not the way it was, but little more elaborate.
and also propose that in the regulatory commissions may not be the commissioners who are of a different level, but at least the staff must appear in an exam. What's the problem? Why are we shying away from that? Let it be 3 years. And the other on the lighter side of it. So one of my professors said, what is the fear? So all of us have one fear of death. The other fear of mine is that I have got a mail from my alma mater that all what we taught you has become obsolete, so your certificate is no more valid. Please come and appear once again in all the tests. I start shivering because I will not pass in even one. But problem with the engineering is also that we, like a debenture, we are encashing it for time. So it has to be, so these certificates have to be revalidated every 3 years. This is just a very humble suggestion. Thank you.
I'll add just one part on this. Mr. Suni, we started, the CER started this regulatory certification program. It is precisely in that direction. There are 3 types of them. One is on the power sector regulation, other is in power markets and renewable energy. And they have end of the exams. And some of the regulators have now started, the staff, they have now started coming for that. A lot of them come from the private sector, from the discoms and all.
The Professor Bose, is there anything of this kind elsewhere, sir? We would like to know if you can.
You mean about teaching this for 2 engineers? Yes, there is, but the problem is this, that there is a whole community of building up already that is outside of engineering, but they're stakeholders in the regulatory process, and they write papers in things like energy economics. None of us read, right? Anybody read energy economics? we don't. But that's where some of these regulatory things come in. And there's a danger to this, going back to what Professor Mahapatra was saying, is that, as Saxena was saying, that there is a full process of feedback that the regulators use. But the regulators don't get that much feedback from the load dispatchers, from the design engineers, they get it from the people who are in economics department, who write regularly about markets, about equity, about all kinds of things. So what you're suggesting is we need to encourage our engineers to actually start getting their feet wet in this.
Before I take the next 2 questions, I have a slip from Professor Srivastava, who's the founder PI of the project. The 2 announcements, photograph will be taken just immediately after the session, number 1. Number 2, the valedictory and feedback session will be held before lunch and after the second session. This is the first session. We'll have a photograph just after this. Then we have the second session, and then the valedictory will also be done before lunch, so the people can plan their schedule after the lunch. And we will have another photograph when the DST and IU SSTF are there, but we will utilize the opportunity to have as many people in the photograph as there now, because some people may move on. So we can take questions from Professor Chandan Singh, Professor Abhijit Mahapatra, both of them.
I don't have a question, I just have a joke.
Joke.
Because I think that the separation between the policymakers and the engineers. So in one of the state legislatures, they said the big problem is the Ohm's law. The legislature said, what's the problem? Bring the law, we'll change the law.
Good one. Professor Professor Venkar, please.
Yeah, so just one small comment. So we are talking about feedback not being received by the regulators whenever any concept note, concept paper is floated. So the regulatory commission does its part so long as procedure is concerned. There is a laid down procedure which is being followed. But has any thought been given or brainstorming, has it been done at the regulatory level, regulators level? Why is that there is not great enthusiasm so long as providing feedback is concerned? So for last few years, many years I've been hearing that, oh, there is no response. There is absolutely no response to this concept paper or white paper or note, etc. That means there is something amiss. So reason could be A, that the paper is such that there is not much impact, so that people don't feel pinch that, okay, whatever happens, it's okay for us, business as usual. Or second could be that people are not geared up enough to, or I should not, okay, geared up enough to provide the feedback. They don't understand it well, so that, and the impact of it in the future, so that they just, don't provide the feedback. So some kind of brainstorming at the regulatory level perhaps needs to be done as to how do we, if at all, we could change the process of obtaining the feedback and all that. Yeah.
It's a very important point. I think formally there is no such sort of a mechanism which is there. But yes, informally things are discussed. But yes, much more can be done to make it more sort of a participative. But now it all depends that which type of consumer, whether we are a common consumer, a retail consumer, whether in whichever category we call it, whether residential, industrial, commercial, who gives the comments on what type of regulation or policy it is. Now, suppose we are talking of net zero. Now, who will give comment on net zero? Whether net zero by 2070? Who's giving the comment onto that? Let us say, I'm just saying that there are various sections of sort of a society or various sections of academia, research, think tanks, etc., who give comments on various types of things. I think it's all depends on what type of regulation, open access regulation. So who will give comment onto that? Now, the necessity is the mother of invention, without any doubt, and we have seen number of regulations. They get refined over time because there's nothing called a perfect regulation which can be there from the very beginning, and it takes time and years to shape it up, and then depending on the problems which come to, and the regulations are refined. I'm not saying that much about the policy. Policy doesn't change that frequently, but then the regulations change and they are done. And I think National Open Access Registry, we are all well aware of. What was the need for that? Because we have very famous case of 15 by MP, I don't know which area it was. Whoever wants to know about the background of, there are two orders of 15 by MP of CRC. Just read it, you will know what is the necessity, what was the necessity. So I think the mechanism is there, the participation is there, but I think the citizenry has to be more informed and influenced about it. Maybe the regulatory bodies are quasi-judicial bodies, like courts do not announce so many things and they do the brainstorming, etc. in that manner. So similarly, quasi-judicial bodies also sort of feel that the people should bring it to the fore. But more can be done without any doubt. Yeah. Thank you.
Moreover, one thing is that important, particularly regulation are just like a dynamic. It is influenced, particularly electricity is one of the subject which is influenced by the legislation, international treaty protocols, as well as the technology. Initially, we can see that 1910 Act come, 1948 Act come after the World War. Thereafter, 1998 Act come, ERC, to bring the efficiency and depart the state government from the part of the territory determination and bring the efficiency in other things. Thereafter, 2003 Act come, where the competitions, transparency, all these things will be bring. So the legislation is also influenced by the number of factors, World Bank, IMF, and as well as other bringing the public sector services parts. So the legislation, whenever change, the regulation are also required to be changed in that fashions, because the earlier nobody has emphasized the development of the selling of the power, surplus power available in one part of the country to other part of the country, power tradings and other things, exchange and other things. So it has been emerging with the development of the technology also. As the technology has been enhanced, that also affected the regulations, because earlier there is no different regions in the country which is integrated as a one nation, one grid type of concept. Now the smart grid, smart technology, digitalizations. So digitalization, decarbonizations are one of two factors now affecting to all regulators to make out the changes in the regulations also. So it is a dynamic type things. When you have prepared a put up. It may be changed after some time also, because the target is previously set up 175 gigawatt, now 450 gigawatt. So the integration of renewable energy, available power at residential places and other things. So injection, whether it's permissible or not, when it will go beyond, then some limitation will be required to be introduced, because it will create the safety aspect also. So it is a dynamic type of things which affect the regulators to change with time as per requirement also.
Thank you, Mr. Pandey. I think now we will assemble for the photograph and before we, okay.